Now most of the problems in this particular topic will fall into three categories. Okay, I call them type 1, type 2, type 3. There will be so many new types of problems which are possible, but largely if you look at different examination papers and all, three major types are there which you should definitely know. Then using that, other things can also be solved. Okay, sometimes there are totally new problems also. I'll try to include that in the problem set, so you'll know that there are some which do not fall into any of the categories. Okay, but most of the problems fall into three categories. Like I said, type 1, type 2, type 3. So now I'm going to discuss the first of them, which is type 1. So what do I mean when I say problems of type 1? In a type 1 problem, what will happen is after you read the problem and you make a diagram, the diagram will essentially be a triangle. Okay, a right angle triangle. And what will happen is you'll know one of the angles, one of these two. Of course, it's a right angle triangle, so you know it's 90. But you'll know one of these two angles and one of the sides. Now the fundamental here is that in any right angle triangle, if you know one angle other than 90 and one side, you can find any angle and any side. It's kind of obvious, is it not? If you know one angle, then you know these two, that means the third one can be found. And if you know one angle and one side, you can find any side. How does that happen? Let's take a look at that. So let us say that this side is given. This is 10 meters. This side is given and this angle is given. Let's say this angle is 30 degrees. Alright. And you are required to find this side, let's call it x. This side, I'll call it hypotenuse y. Or sorry, hypotenuse h. So how do we find this? Well, let's first try to find x. This is tan 30. This is 30. So opposite of 30 is 10 and adjacent to 30 is x. So we can use tan 30, right? Because tan is opposite by adjacent. So tan 30 is 10 by x. Now what is tan 30? 1 by root 3. That is 10 by x. Now rearrange, you'll get x is equal to 10 root 3. It is very important that two basic values, you should learn it up. It will make your calculations very easy. One is that root 3 is 1.732. Note it down. Then second is root 2 is 1.414. These two values are used very, very often. Better to learn it. Okay. I'll just write it here for your reference. Root 3 is 1.732 and root 2 is 1.414. Okay. So now here, what is x? X is 10 times 1.732. So this will become 17.32. Now, you know 10 and you also know that x is 17.32 meters in this case. So hypotenuse can easily be found by using Pythagoras theorem also. But as you will see, it's not as easy. Okay, because you'll have to do a lot of calculations to get that. So even to find hypotenuse, it's advisable to use trigonometry. So now I know opposite and I have to find hypotenuse. Now which is the ratio which is opposite and hypotenuse? Sin theta. Sin theta is opposite by hypotenuse. So I write sin 30. Sin 30 is opposite by hypotenuse. Of course, it's 30 degrees. Now what is the value of sin 30? It's 1 by 2. So you can write 1 by 2 is 10 by h. So what is h? H is 20 meters. See how easy it is? Contrast this, if you were actually going to use Pythagoras theorem, you would have squared 10, you would have squared 17.32, you would have added it plus found a square root. So it would have been not very wise. Correct? So now in type 1, I showed you one example where the opposite was given and you had to find adjacent and hypotenuse. The others are also similarly done. However, I'll show you each type. At least one of each type I'll show you. Here I've shown you opposite and an angle. Next I'll show you adjacent and an angle. And lastly hypotenuse and one angle. So let us look at the second variation of the first type. Okay. So it's again type 1 problem, but we are looking at another variation. In the first case, I took the opposite side and an angle. Now I'm going to take an angle, say of 60 degrees, and the adjacent side. So let's say this side is 5 meters. I need to find this, let's call this y, and the hypotenuse h. So now, let's look at these two, opposite and adjacent. So which is the angle which takes care of opposite and adjacent? Tan theta. Tan theta is opposite by adjacent. So tan 60 degrees is opposite by adjacent. Now what is tan 60? Root 3. So root 3 is y by 5. So what is y? 5 times root 3. I already told you that root 3 is 1.732. So you can write 5 times 1.732. Now instead of multiplying by 5, I am going to multiply by 10 by 2, because 5 is same as 10 by 2. And it's easier to multiply that way. See, 10 times 1.732 by 2. So what does this become? 17.32 by 2. Now division by 2 is quite easy, so use that. 2 8 is 16, then decimal 13, 6 times, 6 times. So 8.66 meters. Y is 8.66 meters. To find h, again we should use trigonometry. H is the hypotenuse. We know 5, which is the adjacent. So hypotenuse and adjacent is involved in cos. So cos 60 degrees is adjacent by hypotenuse. So that is 5 by h. Now what is cos 60? It is half. So half is 5 by h. So now what is h? H is 10 meters. Now, always the side opposite the 90-degree angle, that is the hypotenuse, has to be the longest side in the triangle. So you can see 5, 8.66, 10. So that also seems to make sense. Okay. So these are some basic checks. We have of course done this done these in earlier classes, but it's good to remember. So first thing is what? Opposite 90-degree angle, you have the largest side, because 90 is the largest angle. What is the next angle? 60. And what is remaining is 30. So now opposite 60 you should have the second largest side. So opposite 60 you have 8.66. And opposite the smallest angle, that is 30 degrees, you should have the smallest side, which is 5. So this seems to be checking out for the basic logic also. Alright. So now there is just one more variation left in type 1. We have covered angle and opposite, angle and adjacent. Now we will cover angle and hypotenuse. So let us start with the third variation of type 1. First variation we had angle opposite. Second we had angle adjacent. Now we are going to have an angle and hypotenuse. So let's say the hypotenuse is 5 meters. Now this is the right angle. This is 5 meters. Let's call this x. Let's call this y. And let this angle be 30 degrees. Now which ratio has adjacent and hypotenuse? Cos theta. So let's start with that. Cos 30 degrees is going to be adjacent by hypotenuse. Now what is cos 30? Cos 30 is root 3 by 2. So that is x by 5. Now if you simplify this, you'll get x is 5 root 3 by 2. Okay. So now you need to simplify this further. 5 times 1.732 divided by 2. Now, as usual, I prefer to multiply it by 2 top and bottom, so that it will become 10. 2 here and 2 here. So this is going to become 10 times 1.732, which is 17.32 divided by 4. So now what's the answer? 4 4 is 16. Then you've got 1 3. So 4th is a 12 and again 12. So 4.33. So x is 4.33 meters. Now let's find y. Y is the opposite and we know the hypotenuse. So what ratio involves opposite and hypotenuse? Sin theta. So we'll use sin. Sin 30 is opposite by hypotenuse. Now what is sin 30? Half. So half is y by 5. Sin 30 is half here. So y is equal to 5 by 2, so which comes to 2.5 meters. So this value is 2.5 meters. Okay, so that's basically how the three types are handled. So let me summarize the basic idea for you. So when you're doing a type 1 problem, you essentially end up with a right angle triangle. Now this right angle triangle can be oriented any which way. It's like this, it could be any which way. right? It could come like this, it could come like this, it could even be like this. It doesn't matter how it is oriented, but you'll end up with a right angle triangle. And you'll know one side and one angle other than the 90-degree angles. Using that, you'll be able to find any side and any angle. So I showed you a case where I gave you theta and I gave you one value, say x, and you had to find this and this. So what did you do to find this one? You knew this was opposite, adjacent was given. Opposite by adjacent is tan theta. So you simply write tan theta is opposite, let's call that y, by adjacent. So if you cross multiply, this becomes x tan theta, and you can find this. Next, if you have to find hypotenuse, adjacent and hypotenuse are involved in cos. So we can use cos theta is adjacent by hypotenuse, right? So what is the hypotenuse? Hypotenuse will be x by cos theta, or x secant theta if you want. So this way I can find all the sides for this triangle. Second case I showed you, if you know the angle theta and the opposite, so opposite is y. Now what do you have to find? You have to find x and h in terms of y. So first again you use tan theta. So what is tan theta? Tan theta is opposite by adjacent. So now we already know y, we have to find x. So x will become y by tan theta, or y cot theta. No need to learn anything in this, right? Don't mug this up. You just need to know how to do it, that's enough. No need to mug it up, because it's extremely simple. Not very wise to mug all these things up. Now if you have to find hypotenuse, you already know opposite, so use sin theta. Sin theta will be what? Opposite by hypotenuse. So h will be y cosec theta. This will be y cosec theta. And the last case, you know theta and you know hypotenuse. You have to find base or adjacent and opposite. So again, let's use sin theta first. Sin theta is y by h. So what is y? Y is h sin theta. So this part will become h sin theta. And to find x, we'll use cos theta. What is cos theta? X by h. So what is x? H cos theta. So this will become h cos theta. So this is how all the variations in type 1 can be handled. We'll do a few problems and you'll see this is the simplest of all problems, simplest of all the types. Very easy to solve this. Let's start with the problems.